Now, let's talk about the equations of tangent and normal at any given point. The first thing that we have to find out the gradient of the tangent and the gradient of the normal. The normal, you have to know that the normal is always perpendicular on the tangent. So I know that the gradient of the normal is equal to -1 over the gradient of the tangent. And you have to know that the normal and tangent are straight lines. So, in order to find the equation of any straight line, to find the equation of a straight line, we need the first thing we need a point on that line. And the second thing we need the gradient of the line. Let's have a simple example now. Find the equation of the normal to the curve y is equal to 3x squared minus 5 at x equals 2. The first thing that we have to do is to find out the gradient of the tangent. So the first thing I need to find out dy over dx, which is equal to 6x. Then I need to substitute the 2 in my first derivative to find the gradient of the tangent. So dy over dx at x is equal to 2. This is equal to 6 times 2, and this is equal to 12. So by this, I find out that the gradient of the tangent is equal to 12. And we know that in this question, we want the gradient of the normal, not the gradient of the tangent. So by this, the gradient of the normal now is equal to, I flip the gradient of the tangent, I then take the negative value of it, so it's -1 over 12. Now, for finding the equation of the straight line, I have my gradient of the straight line. The second thing that we have to do is we need to find a point on the curve or on the line. So to find the point, I know that x is equal to 2. So simply I substitute this point in my original equation. So y is equal to 3 times 2 squared minus 5. So the value of y would be 12 minus 5 is equal to 7. So now I know that my point is 2 with 7. So now to find the equation of the normal, I have the gradient of the line and I have a point on the line, and then I can find the equation of my normal using what we learned in previous lessons. Now let's solve a question from the IB question bank. Consider the curve y equals 5x cubed minus 3x. The first part of the question, we need to find the first derivative. So dy over dx is equal to, I must multiply the 3 times the 5, it gives me 15, x squared and minus 3. Always when I want to derive x having the power of 1, I simply take the coefficient of the x. Now the curve has a tangent at point P, which is minus 1 and minus 2. I have this point. Part B of the question, we need to find the gradient of this tangent at point P. So I want to find the value of the first derivative at x value is minus 1 at x equals minus 1. So this will give me 15 times the minus 1 squared minus 3. So now this is equal to 15 times 1, 15 minus 3, 12. So I can know that the gradient of the tangent is equal to 12. Now for part C, find the equation of this tangent, give your answer in the form y equal mx plus c. So to find the equation of this tangent, I use y is equal to 12x because I know the gradient is 12 plus c. And then I use my point, which is minus 1 with minus 2 to find the value of c. So when x is equal to minus 1, the value of y is minus 2. So I have minus 2 is equal to 12 times minus 1 plus c. So the value of c now is, I have minus 12, take it to the left-hand side, it becomes 10. So the equation of the normal is y equal to 12x plus 10. This is the equation of the tangent at the point